read about linear regression and discussed about the basic concept of linear regression. Now we will go further in linear regression and we will study linear regression, advanced concept, then polynomial regression, and then additive linear model for linear regression, additive linear model. So that is a kind of linear regression problem. So we have learned that we need to find the best fit for the data. So the main aim is to find the line which best fits the given data. So we want to find a line which generalizes the given data. So if we see this blue dot, these are the data points given to us to describe this in a function. For example, this dot, these two, and these are dot given. These dots are already given. So our aim is to find the best fit for this given point. This function could be, say, as f of x, function of x, with x in x's and y in y-axis. And this point is represented by a 2-point value because this is a two-dimensional view. So we say that a point is located on xy position. So, for example, this point, if we suppose this line is divided into some other point, and we say that 1, 2, 3, 4, 5. So this is like 4, and here 1, 2, 3, and 3. So this point is around 4, 3 point. X is 4 and y is 3. So this is represented by a 2 value. This point is represented by a 2 variable xy, which is a two-dimensional point. Then, so if we represent this, because there are multiple points, so we represent this function in. So earlier you have seen this kind of graph where 2 points were given like this, and you represent this by a simple line equation where f of x is equal to w0 plus w1 x1. So this was the equation, this error equation where we represented these 2 points by this simple equation. Now the number of points increased from 2 to many. So for that, the equation becomes larger or becomes much complex. So now this equation will be represented by many points instead of one. So similar to the earlier equation, the first point is W0. The first weight is W0 where X0 is 1. So this could be represented as X0 W0 where X0 is 1. So that's why this W0 is without X. And then W1, W2 up to WD. So there are D points in X-axis. So for that, because there is no X in this one, so we represent this whole summation into this form. Is this clear? Any confusion with this representation? Online students.
Clear है sir.
Clear?
Yes, sir.
Okay, so how about if there is a negative sign, a plus sign? How will you do that? How this equation will change? For example, instead of this plus sign, not in this case, but in some other case, if instead of this plus sign, there is a negative sign. So how will you represent this equation in this form? Any idea? G, online. Simple summation. Simple arithmetic rule.
प्लस को
Yes,
सर सिर्फ माइनस कर लेंगे जो समेशन से पहले प्लस है.
so you mean like this? This plus should be converted to this one.
यस सर.
Yeah, that is also. This is actually the answer. So you actually write it in parentheses. So and inside parentheses there are summations. So when minus is multiplied, so every term becomes negative. Hmm? Minus is taken a common from all. In this case, if there is a concept, a question is raised about negative and positive. If that is in a series, so then you write this way. For example, summation j is equal to minus d2 plus d. In this case, it will start from minus wd xd2 plus wd xd, because the starter is minus d. So minus d will increase to 0 and then increase to plus d. In that case, j will be equal to minus d or some other variable with minus sign. So is this clear? Any confusion? Okay, so we have n samples. N samples. If there is no number, then we represent this in. We say that a variable n. So n could be any number from 1 to n. N is maximum. Where d is data points. Okay, where each d is a 2D point. We are located in a two-dimensional space. One is x1, for example, this point and this point. So this will be represented by xi, yi. So any given point is represented by x and y in that, for example, for any di, there are 2 points. Xi, I mean a single point is represented by 2 variable, an x domain and y domain. And any xi could be from 1 to d, because there are d dimensional space or d dimensional representation. Y is the output for xi and y is already given. In that case, if you have already solved a problem where y was given 0, 0 and 0, 1 and 1, 1, like that, where y is already given. Why is the output? Is the output given by the, where is it is required? We want to find a line f of x. F of x, so line means a function. So we want to find a line f of x which best fits d. D points. D points mean these points. Data points. What does best fit mean? Best fit means. Best fit means make function x close to y as much as possible. Like this. like this. Draw this equation. It could be like this. It could be like this. It could be like this. Multiple lines. So you will try, you will see which function is more closer to the points. So then find f of x, find that function, that line, that line which minimizes this error. Which error? Where f of x, the defined function, minus the label or the given function and their summation. This is actually error function. Okay. In other words, there are dw's for each point which minimize error function given that the argument. So actually this is the representation of what we say in word, the mathematical representation. Actually this is the data points given to you, this label or these points, and you just need to find this function so that the error between this data, given data, and this function which you are already supposing becomes near to zero. So actually, so you want to minimize the error function, which is mathematically represented this. This function, what this function says, argument w for any weight, for weights w, where here in this equation w is r, d. And in our earlier equation, we have only two, 0, 1 and 0, w1 and w0. So in that equation, we have w0 plus w1 x1. In that equation, d is 2 or 1. D is 1. So in this equation, we generalize that equation to d times. So d could be any value from 1 to any d. So previously our equation was like this. Remove this one. This was our equation. Remember? So now it is generalized for more data points. Which one? Oh yes, that was for 2 points only. So it is for many points. For example, this was your 2-point system, this one. This one. No points, number of points are increased, So you need to enlarge your function for that number of weights. So, and this is our error equation, error function, cost function, or cost function. So we can write this equation in alternate way like this, because W0 remains same and this summation slider is converted to this summation sign. Okay, from W1 to this is 1 and this is D. From 1 to D. Okay, and W0 is here. In other words, W which minimizes this error function. So there are two error function if you can differentiate. One is squared error function. It is called squared error function. It's squared. And this is simple error function. So mostly this square error function is used for calculating the error. So our problem becomes this one. Generalized problem. We want to generalize this equation for any number of data points. First we solve for 2 points. Now we want to solve this linear regression problem for all data points. So for that we need a generalized equation, a generalized representation of the problem. So our problem can be stated as find W, which is a vector of W's, which minimizes this error function, squared error function. And our main function or baseline can be represented by this equation. This is general equation. When we will find the W's, then that will be our exact equation to the given points, because only W's matter. Otherwise, equation is same for all points. So the style of line actually is dependent by the W's. The length of line is dependent on W's. For data point D, and where D, every point is represented by two value in two-dimensional space. Clear? Any confusion? How to solve this? The problem is how to solve this problem. We have an error function and we have a general line equation. General error function and general line equation. Okay. So question is how to solve this problem. If we solve this problem, we can derive best fit for any data. Only you need to solve this error function with this equation, where you need to find W's. Clear? There are various ways to solve. You have already tried, I guess, two methods. One is by simple math, second by gradient descent method, and third one would be next one, the vector one. Here, the simplest one will be presented. So we will derive a simplest method to solve this equation. But remember, this is all the derivation of that method, where in the end you will see the simple method. So you need to derive that method first, then you will understand the value of that method. So let's discuss this in later classes. Any question till now?